image, etc. Psalm 103, know ye that the Lord, he is God, he hath made us and not we ourselves, his people and the sheep of his pasture. Now keep in mind, the fertilized egg in the freezer, implanted into a surrogate pregnant mother, ultimately is still God's creation. I mean, there's nothing different about that. But ultimately, if we allow the sin nature to prevail over decades to centuries ahead, I wonder what's going to happen to those embryonic stem cells and embryos in terms of man's ability to manipulate them. And that's what the fear really is all about. The sanctity of human life. Job 10:9, remember I beseech thee that thou hast made me as the clay, and wilt thou bring me unto dust again. In Isaiah, thus saith the Lord that made thee and formed thee from the womb will help thee, fear not. And then God is active even in the event of conception. Genesis 29, 31, 32. And when the Lord saw that Leah was hated, he opened her womb. But Rachel was barren, and Leah conceived and bore a son, and she called his name Reuben. For she said, surely the Lord has looked upon my affliction now, therefore my husband will love me. And in Ruth, so Boaz took Ruth, and she was his wife. And when he went in unto her, the Lord gave her conception, and she bore a son. And then God knows the unborn. One of my favorite passages is this one. For thou hast possessed my inward parts, and hast covered me in my mother's womb. I will praise thee, for I am fearfully and wonderfully made. Marvelous thy works, and my soul knows right well. My substance was not hidden from thee when I was made in the secret, intricately wrought in the lowest parts of the earth. Thine eyes did see my substance, yet being uninformed. And in thy book all my members were written. In continuance were fashioned when as yet there was none of them. So, I mean, the idea of the Lord knowing each and every one of us before ever conceived is well supported biblically. And I presume he knows the infants that are going to be born from these frozen embryos too after implantation. So God's in control and knows each and every one of us. And God knows the unborn. And just, you know the story of Mary and Elizabeth. And it came to pass that when Elizabeth heard the greeting of Mary, the babe leaped in her womb, and Elizabeth was filled with the Holy Spirit. And she spoke out with a loud voice. And she said, blessed thou art among women, blessed the fruit of thy womb, etc. So you know this story. So the point is, I'm telling you something here that we all know and accept by faith. So DNA by design, the language in which God created life is the DNA. It's a spectacular creation. And one thing that's somewhat encouraging that you may have noted is Francis Collins has been appointed as the next director of the National Institutes of Health. And Francis Collins wrote a book about a year and a half ago called The Language of God. And Francis Collins is a man who fears God, and he is your next director of the National Institutes of Health. So he believes that God implanted in the DNA the secret of life, and ultimately we are his creation. So this is an encouraging appointment, and Obama made it. So I'm somewhat encouraged by that. But perhaps science will take us beyond the need for embryonic stem cells, and that's where I'm going to turn the story a little bit to something a little bit more encouraging or more favorable. Future clinical applications of adult stem cells for tissue repair and regeneration. It's really an overview of the recent events that I think have challenged the traditional concepts that adult stem cells have limited potential. Now, I'm going to make an assumption that adult stem cells, for most of us, are going to be kind of an acceptable way to move forward with science and medicine. Maybe some will not agree with that. Let's take a look at that. So, again, what's shown on this slide, and it may be difficult to see, at least for me, and I'm sure it was for you, but the lymphoid cells only become certain types of blood cells, and the myeloid stem cells only become certain types of blood cells. So this is the multipotent stem cell concept. But what we're looking at now is the challenge before us, and that's reprogramming adult human stem cells into embryonic stem cell-like cells. So here's the conventional woman whose egg is fertilized. We have the blastocyst, and embryonic stem cells are derived from that fertilized egg. But here's a new way of doing things. The so-called induced pluripotent stem cells are cells that are harvested from very simple places like skin or adipose tissue or other organs of the body. And these cells are put through a series of steps in the laboratory and exposed to certain what's called transcription factors that now generate a pluripotent stem cell. And this field is moving so rapidly. And what Dennis Roop said to me yesterday when I was speaking to him about my talk tonight is he said he thinks within a couple years this whole embryonic stem cell thing is going to be history. That everything is going to be turned to making these pluripotent stem cells out of adult stem cells and giving them infinite replicative capability. Now, there are still problems, but yet this is where the field is currently going. Let me give you an example about how this might work. This is a CAT scan of a picture of a woman whose airway is incredibly narrow. This is her trachea. And this trachea is very diseased and narrowed. She's very short of breath and having trouble breathing. So the windpipe transplant is something that has now taken a trachea out of someone who's just died, and it's chemically treated so that all the cells of the donor are now eliminated. So there's no transplant issue here. We've got cells that have been destroyed in this windpipe, if you will, and stem cells have been taken from her blood and made into pluripotent stem cells, and they then are placed in a chamber that allows a kind of a circulatory bath to allow these cells to plate. And over time, her stem cells that are now pluripotent and exposed to a particular type of atmosphere in the laboratory are made sufficiently capable of budding down. And now what we're looking at here is her trachea before the operation, the narrowing here, and now she's had the transplant. She left the hospital 4 days later with effectively an open airway using her own bone marrow-derived stem cells. Again, adult stem cells made now into airway cells. Again, bone marrow stem cells don't become airway cells. They become blood cells. So here what we have is an example of making pluripotent stem cells out of adult stem cells and really creating cells with the ultimate capability of going in many directions in terms of their value. Here's another example. Amyotrophic